To wrap up this chapter by discussing energy and temperature. So we just talked about how chemists study matter, and there's different types of matter. You can classify it. There's also different forms of it, and so on. The same thing is true for energy. So energy is the other component of the substances that we study. Energy has a very specific definition in chemistry and physics, and that is the capacity to do work. So really anything that contains that capacity to do work, where it could be released to do that work, that substance will contain energy. Work here has a very specific definition as well, which is the ability of using a force to act for a given distance. Now, this might sound like something that you don't really recognize, but if you think about, say, taking a book from the floor and putting it on a bookshelf or on a desk, you basically are using force to move an object a certain distance away, and so you're doing work. If you push a car or a bicycle on the road, that's doing work because you're utilizing force to move an object a certain distance away. There are work that's done that's maybe not as clearly seen. So for example, if air in the form of wind pushes paper around, the air in that case is doing work on the paper, right? Because it's utilizing force to move that paper a certain distance away. So there's really many different examples of work. All of that work that's done is really an indication that that object has energy in it. Now, like matter, energy is conserved, meaning that you can't really create or destroy energy. The amount of energy in the universe is constant, and this is what's given as the law of conservation of energy. So you have a certain quantity of energy in the universe. It's always there. You can change it from one form to another form, but you can't really make more of it or destroy it, okay? And so what are the different forms of energy that we can have? Well, there's really two main forms that we know of. One is called kinetic energy, and the other one is called potential energy. Kinetic energy is the form of energy that involves anything that's moving. Anything from really big stuff to really small stuff. Anytime they're moving, then you can consider that that object has kinetic energy. So for example, the easy one would be to look at a moving car. That car has a kinetic energy. You can see that when it transfers that energy to something else. So if the car hits another car, the car hits a wall, the car hits a tree, you can see the effect of that energy transfer on the other object. If an air is moving, we call it wind. Wind exerts pressure. You can feel it if you're walking in a windy area. You feel like you're being pushed around by that wind, right? So that is an example of the air, which is composed of different gases, is moving around and push the objects around it, and so that's an example of kinetic energy. There's some other examples that's not as easily visible to us. Electrical energy or electricity is really the result of moving electrons. So electrons is a really tiny subatomic particle that we would discuss a little bit more in future chapters, but the reason we have electricity is because electrons are moving from one location to another. It turns out that atoms, which make up all the matter that we know of, also moves around. So you might look at your book, for example. Your book is composed of papers. The papers are composed of molecules, and the molecules are composed of atoms. Those atoms, even though it looks like that book doesn't really move around at all, the atoms in the molecules are actually moving around, but they're not moving around with large motion. They're moving around in very small motion. You can't really see them, but they have these vibrational motion that occurs between the bonds of the atoms that connect the atoms to form the molecules. These kinetic energy we often also call thermal energy because they could be measured using temperature. The other type of energy is something we call potential energy. This one is a little harder sometimes to see because it's the energy that comes about because of the way a particle or an object is composed or the way its position is relative to some other reference position. The really easy one to see is the gravitational potential energy. This is when you take an object and you put it above the ground at a certain height. You know that that object will fall down, and when it falls down, it releases some amount of energy. How do I know it releases some energy? Because I could hear the sound of that object falling to the floor. And so that sound is generated by the object releasing some amount of energy to the surrounding air. Now, the amount of energy can be calculated by how high that object is relative to the center of the earth and then the mass of that object. So that's what we refer to as gravitational potential energies, the relative position of that object to the center of the earth that gives it that energy, that gravitational potential energy. Turns out that molecules also have potential energy. Their energy, they're stored in chemical bonds. This is something we will discuss a lot more later on. Now, one of the things to know about energy is that they always accompany chemical reactions. So we talked about chemical changes in the previous video. So chemical changes or chemical reactions are accompanied by an energy change. So if the reaction, or either chemical or physical, release energy, then we call those exothermic. You can know that a reaction is exothermic because you will see that the surrounding, which is you or other objects that touch that particular system, gets hotter. Burning of gasoline is an example. You do that in your car all the time, you can feel that car gets hotter, right? If you metabolize food, as soon as you eat some food, your body actually warms up a little bit. And that's because the reaction where the food is broken down into smaller things, it releases heat or energy. You burn natural gas in your house, for example, in your water heater. You burn gas that comes in through the pipe, and that causes the water to be heated up, right? So again, the reaction is the burning of the gas, but the way we know it's exothermic is because it releases heat to that water. So the way we understand whether it releases or absorbs energy is by what the effect of that reaction is on its surrounding. The same thing with the reaction that are called endothermic, which is where it absorbs energy from their surrounding. So the word therm, by the way, refers to heat. Exo means to expel, so to release, and endo means to absorb or to take in. So what are examples of reactions that are endothermic? Well, these are reactions where you have, for example, in a cold pack, if you put the cold pack near your hand, you can feel that your hand feels cold. Well, the reason your hand feels cold is because energy has been absorbed from your hand into the cold pack. So again, the reason you know that this is endothermic is because you see the effect of that reaction on the surrounding, which in this case is your hand.